Is my voice audible? Good evening, students. How are you all? So myself Saurabh Gandhi, I will be teaching you foundation, and today we are going to start with the electricity chapter, one of the most important chapters in entire science, and we will be trying to start this chapter from the very basic. Is my voice audible? Good evening, good evening. Okay, so shall I start with this chapter? Okay. Okay, so we will be starting with a very basic thing. You must have heard, every one of you must have heard about electricity and its importance in our life. So we will start with the basic concepts and then we will delve into the more important and numericals aspect as well. So very basic question. Many times people ask me, many times many students ask me, is it possible nowadays to live without electricity? Have you thought about it? What would be the value of life if we are just having it without electricity, no electricity at all? Would we able to start this YouTube live without electricity? Would that thing be possible? And so electricity is very important. It is one of the key aspects by which we are able to manage so many aspects of our life, whether it be heating, whether it be lighting, whether it be providing the energy for different household aspects like your television, your mobile phones and different aspects. So have you ever thought about what are the major sources of electricity, how electricity is coming to our homes? Have you ever thought about this? Yes, please, you can write. I am seeing your comments. Please, you can write your comments. What are the major sources of electricity? How electricity comes to our home? Hi Dilip, hi Sanjeev. Okay, what do you think? What would be the major source of electricity? How electricity is produced? How it is? Okay, electricity grids, very good. So these power stations, these are one of the most important aspects when we talk about electricity. What are these exactly? There could be many types of power plants. Nuclear power plants. What is the main fuel of nuclear power plant? Uranium. And a natural gas power plant. There could be coal power plant, geothermal, hydroelectric, wind power plant, solar power plant. So different sorts of power plants are there, and I am assuming that you must have seen many of these power plants, not the biggest form of these power plants, but at least small miniature of these plants. And those things you must have seen. So these power plants are the main sources of electricity, and due to this, electricity is produced and it is transmitted to various substations and ultimately to our homes. And from the switchboard or main board, from that place we are getting the electricity to our appliances. Now again the question comes that we have two sorts of electricity. One is the alternating current, we won't be getting deep into that, and second is the direct current. So what are these forms and how are their uses? So many things are related directly and indirectly to electricity. Let's come up to one more thing. This is the objective of our chapter. Currently we are performing this chapter for class 10th, and these various aspects will be the basic aspects. Like very first thing is electric current. We would be knowing about electric current. Second aspect would be the voltage or potential difference. We will be talking about this as well. Electric power. We all know that there are some bills, electricity bills, which are coming to our homes on the regular basis, and how those things are managed, how those things are calculated. We would be getting deep into the electric power aspect as well. It is also related to electrical consumption. There are different circuits and circuit symbols associated with the circuits. Then there is this electric charge. Although this is prior to the electric current, we will be talking about this in this particular chapter only, in this particular session only. Then there is an opposition to the current, which is known as resistance. So there are so many aspects related to electricity, but in your syllabus there are very few, and we are going to tackle all of them in this very aspect. So are you there with me now? Okay, thank you. So initially we need to understand what are the types of charges. I mean, you would be saying, sir, types of charges, we are not kids, we are grown-ups now. Okay, so starting with the types of charges is prominent, because if we are able to understand the types of charges, later on we would be able to how these charges are flowing in the conductor and what is the electric current actually. So there are two types of charges. One is positive charge and second is negative charge. We know that negative charge are electron, and electrons are playing very vital role in your flowing of electricity or flowing of electric current. So there are two properties. We know that opposite charges, I mean negative and negative, they would be opposing each other, and similar charges, they would be opposite charges, that is positive and negative, they would be attracting each other, and like charges, they would be repelling each other. This diagram is very important to understand the flow of charges. If we are not providing any voltage, then the electrons are known as charges. They would be roaming around differently in all directions if we are not providing any voltage. What is voltage? Voltage can be of two ways. Either it could be provided with the help of cells or your batteries, that will be DC voltage, or directly alternating as we are getting into our homes. So anyone knows that what is the voltage we are getting in our Indian homes? What is the value of that, or maybe range of that? Yes, what could be the range of voltage which we are getting into our Indian homes? Okay, so in India, in UK, in China and many other places, the voltage range is provided from 220 volts to 240 volts. And similar is not the case with every place. In US, for example, the voltage range is around 110 volts. So it is different. When we will be coming on the potential difference in voltage aspect, then we will be discussing about this. Yes, Divya, it's not 10, Divya. It would be around 220. If you would see any appliance or adapter of your mobile phone or your this laptop charger or any other aspect, you would be seeing that there would be a rating of the voltage, rating of the power, rating of the current. So it would be mentioned like this: 1 ampere, 220 volts, and maybe 5 watts. This sort of rating you would be finding in any appliance. So now coming back to this, what are the flow of charges? When no voltage is applied to a conductor, what is a conductor? Conductor could be any piece of metallic element in which electricity can flow, and insulators are in which electricity cannot be flown. So with no voltage, they would be roaming around differently. Now when we see that there is positive and negative terminal, everyone has seen the batteries, no? The batteries which we are inserting in our games or any other aspect. Yes, they have one positive terminal and one negative terminal. So when this battery is applied, electrons are of negative charge. So what do you think? What would be the flow of direction of electrons? They would be going to the negative charge or to the positive charge. What do you think? What would be the direction? we know that like charges repel each other, right? And unlike charges are attracted towards each other. So these electrons, when a positive terminal of battery is provided to them, they will be attracted towards that positive terminal. And so what will happen? There will be a flow of electron in this direction. Electrons will be flowing in this direction. Hope this concept is ready. Okay, so we will be moving to the next concept. These are a few examples of conductors and insulators. I have taken a few photographs. So if you see that these are the copper wires, these are the copper wires, and the outside covering of a copper wire, it is known as insulator. Similar is the case with this, our 3-pin plug. We all must have seen it, or many of us might have broken it down as well. So the metal pins are conductor, and the case is insulator, so that we are protected. Now most of you must be having some doubts regarding that, sir, why is it always that it has 3 terminals to it? What are the meaning of these 3 terminals? So we would be seeing this image. There are 3 wires attached to it. 3 wires coming from the main circuit. So these wires are known as, the very first and very important wire is known as live wire. It is always of red color. And what its purpose is, it is the main wire which is coming to your electrical appliance, and this is providing this electrical appliance the energy, electrical energy. Then there is second wire, this neutral wire. What is the meaning of neutral wire? This neutral wire is to provide a completion of circuit. If the circuit is not complete or if the circuit is incomplete, then there would not be a flow of electricity to that appliance, and ultimately we won't be able to use that appliance in which way it was required to be used. Now these two are okay, and we know that one would be incoming and second would be completing it. What is the meaning and reason for providing the third wire, that is earth wire? Yes, please write it down in the comment box. What is the meaning of this earth wire? Why is it required? Okay, in case of, sometimes what happens, there is a surcharge of electric charge in an appliance, or due to any abnormality of that electrical appliance. So we need a protection wire. So that protection is covered by earth wire. So that is why earth wire is required and used. Okay, so now let us start with a very example, and I require all of you to answer this question with me. Very simple question. We need to calculate these two questions are same. We need to calculate the number of electrons constituting 1 coulomb of charge. Very simple question. We need to find out number of electrons in 1 coulomb of charge. The SI unit of charge is coulombs, or we write it by capital C. Please write it down. Okay, so let us see how this numerical has to be covered. We know that 1 electron has 1.6 into 10 raised to the power minus 19 coulombs of charge. And we all know about this. We have read it in class 9th as well, and it was initialized in class 8th as well. So this is the charge we know. Now the question is, we need to find that 1 coulomb of charge, how many electrons would be there in 1 coulomb of charge. So this is, these many coulombs of charge are having 1 electron. If I state that 1 coulomb would be having, let me divide both sides by 1.6 into 10 raised to the power minus 19. So it will become 1 upon 1.6 into 10 raised to the power minus 19, and same thing will be happening over here. So these two entities will be finished. It will left with 1 coulomb, and this will be the value which we have to calculate. Let us also calculate this. So we know a property of maths that 1 upon 10 raised to the power minus a could be any power. This is equal to 10 raised to the power a. That power becomes positive, and so let us calculate this as well. This will become 1 over 1.6 into 10 raised to the power 19, है ना, because 10 raised to the power minus 19 would be there. So now solving it, we are taking 10 from here, and this will be left with only 18 and 1.6. So it will come out 6.25 into 10 raised to the power 18 coulomb, sorry, electrons. These many electrons would be there in 1 coulomb of charge. So these many electrons would be there in 1 coulomb of charge. Okay, so hope this numerical is clear, but this was very basic numerical. What you might be asked, they could ask you that what could be the number of electrons in 10 raised to the power 5 coulombs of charge. It could be 118 coulombs of charge. They could increase the value, but the question is very simple. We first of all we have to find out 1 coulomb, then later on we have to multiply it by the number of electrons. Okay, so coming to the next thing, electricity is covered in two parts. One is known as static electricity, and second is known as current electricity. If I just zoom it out, so static electricity is just a one-time event. Apart from that, the current electricity is a constant thing. And second thing, the current electricity and static electricity, it is generally the charges are built up on a one direction or a one location, but current electricity we already know. So our focus for this chapter would be for current electricity only. Now coming to the electric current, one of the major quantity and requirement of this. So this is what the rate of flow of charge in 1 second is known as, in a unit time is known as electric current, and it is denoted by capital I. So if you have to define it, so it will be defined as current will be equal to charge upon time. What will be the value of current? Current will be equal to charge upon time. So I is going to be equal to Q upon my time. Sometimes we write this Q as a small q, and sometimes we would be writing it as capital Q. So we also need to understand their SI units. Current is measured in amperes or capital A. Q is measured in coulombs, we have already defined it as capital T, and time is measured in seconds. So these will be the SI units of these. Now we also need to understand that sometimes the value would be different. When we would be preparing for the numericals, the value are not going to be same. For example, this kiloampere, whenever kilo is applied, so these are multiple units, and second are sub-multiple units. Multiple units means that the powers are positive, and sub-multiples powers are negative. So kiloampere, in case of kiloampere, it will be 10 raised to power 3. Kilo coulomb, 10 raised to power 3 coulombs. Kilometer, 10 raised to power 3 meters. Kilograms, 10 raised to power 3 grams. Similar to the case. And when mega is there, capital M, so it will become 10 raised to power 6, as mentioned over here. Now sub-multiple units would be milli and micro. These two terms would be there. And when we talk about milli, okay, is my voice better now? Is my voice better now? Okay. So coming back to this point, so milliampere would be 10 raised to the minus 3 and microampere would be 10 raised to the minus 6. These things you have to write it down in your notebooks because these will be asked in later numericals as well. Many a times we are asked about 1 ampere definition, and the 1 ampere definition is being asked. So this is what the net flow 1 ampere, when the net flow of charge per second through a cross section is known as 1 coulomb. So this is what the definition of the net flow of charge per second through its cross section is 1 second in 1 coulomb. Now one main property is also referred as quantization of charge, and it will be used in various numericals. So this will be as Q is equal to Ne. Q is obviously charge, N will be number, and here it would be number of electrons, and E would be charge on one electron, that will be 1.6 into 10 raised to the minus 19 coulombs. So we have two formulas now. One is I is equal to Q upon my T, and second is Q is equal to Ne. So these two formulas would be required in later numericals. So these two formulas are there and we would be requiring them. Now coming to a very simple numerical once again. A current of 5 ampere flows through a circuit. A current of 5 ampere. So please perform this numerical. Okay, so let's solve this numerical. A current of 5 ampere flows through a circuit for 15 minutes. Calculate the amount of electric charge that flows the circuit during this time. So we will be understanding what values are given to us. So we have been given with a value of current, that is I, 5 ampere. We have given a value of T, that is 15 minutes. But we know that SI unit of time would be seconds for these case. So we would be finding it 15 into 60. Is my voice better now? Okay. So now we have to 15, 6, that is 90 and 900. So that will be 900 seconds. Now we know the formula, we have to calculate the amount of electric charge. So it will be Q is equal to I into T. Why is it so? Because I was equal to Q upon my T, and from this we have formulated this formula. Now putting the values into this, Q is equal to I would be 5 amperes and T would be 900 seconds. So ultimately the value would be 4500 coulombs. So this is how we have to calculate this. Okay, this was very simple numerical. Now coming to this, An electric bulb draws a current of 0.25 ampere for 20 minutes. We need to calculate again the amount of electric charge that flows through this circuit. इंटरनेट तो सही है उसकी सुविधा, ये ओबीएस का ही सेटिंग का होगा इशू। तो अभी वही अभी कुछ कर नहीं सकते, अभी हमें समय देता हूँ। बताओ फिर क्या कर सकते हैं सर्विस में। इंटरनेट तो मुझे मैं स्पीड भी देखी है, स्पीड तो 120 एमबीपीएस आ गया। हाँ भाई चलो मैं को देखता हूँ। तो कैमरा सही दिखता है क्या? एक्चुअली ओबीएस बंद करूँगा ना तो स्क्रीनिंग बंद हो जाएगी अगर ओबीएस नहीं करूँगा। पर वो सेम स्क्रीनिंग शायद स्टार्ट नहीं हो गई, तो उसमें ये ऑप्शन आता है मेरा अपनी फ्यूचर स्क्रीनिंग बंद हो गई। वो कैसे करो फिर एक बार करो या हाँ पीपीटी शेयर करो। वो आईपैड से मैं आईपैड दोबारा करके देखता हूँ। हाँ जी हाँ वही तो दिख रहा होगा। हाँ जी नहीं डायरेक्टली आएगा। ये आईपैड का नहीं है, ये ना ये आईपैड का नहीं है, ये इशू है इसका ओबीएस से, क्योंकि उसमें कुछ वेटलाइट वगैरह होते हैं, उसका कुछ पंखा होता है। और मेरे को लग रहा है शायद पास की से ना मतलब किया था तो कह रहा था ये वाली चीज़ कुछ तो हुआ था, तो वो कह रहा वो रिकमेंडेड है कि आप उसकी क्या यूट्यूब पे डालें। अभी पर वही एकदम ये वाला लैग करेगा, या तो एक बार कंटिन्यू करो, एक बार पढ़ा तो देखी जाएगी इसी में, और जैसे ही वो लैग वगैरह करेगा वो पढ़ा देगा, अगर थोड़ा बहुत कुछ आएगा क्योंकि लैग करके कुछ भी नहीं आया। चलो मैं एक बार देखता हूँ। पर अभी ना इसकी स्ट्रीमिंग हो चुका ना, अभी कुछ नहीं करने का स्टेटमेंट नहीं आएगा। अभी कुछ नहीं हो सकता। ज़ूम पे बच्चे भी ला दो, अगर ला सकते तो ज़ूम पे कुछ करके वैसे कुछ कर दें। ठीक है भाई, गेम में जो कर जो करवा लेंगे, दोबारा करवा दूँगा आपको। ठीक है। Hi students, my apologies. Is it better now? Okay, now come moving to this question. So the question is being asked that an electrical bulb, it draws a current of, that is I of 0.25 amperes for time 20 minutes. We know that we have to convert this time into seconds. So it will become 20 into 60, that is 1200 seconds. And we have to calculate the amount of electric charge, that is Q. So again putting this into the formula, Q is equal to I into T. So this will be 0.25 into 1200. Now from these two zeros, this will be calculated 20. So this will come out to be 300 coulombs. And these are very simple examples. Now moving to a better example and a difficult example. Not so difficult, but yes, upgrade.